we all know that when you ask most people about who invented radio, the name that comes to their mind is Marconi. And of course, we know that there are many people working in the field, um, and among them Hertz, for example, who was the first to demonstrate that there were such things as electromagnetic waves, and nobody really knew what they were. They were pretty much laboratory curiosities. Here is Hertz showing his transmitter and receiver, the transmitter a spar cap and two paddles for the antenna. And then the detector is the ring with a couple of balls. They were much more closely spaced than it shows in this illustration. But it got the point across that when the spark gap jumped the gap on the transmitter, you'd see a small gap in the receiver. So many other things were going on at the time. The thing about Marconi, I think most would agree, is that he was able to see the future in this and bring together these components and ideas and laboratory curiosities into a system which not only worked but could make money. That was the big deal. So there he is. We have 237 pictures of Marconi. In none of them is he ever smiling. And that was purposeful. He wanted to be taken seriously as a man of consequence, a man of respect. And I guess he thought that that countenance would help him along that line, because especially in his beginning days, he was quite a young man. And even though he was born in Italy, spoke excellent English. He did speak excellent English, but still, he really wanted to make sure that people would take him seriously. And he had the good fortune of being born into a family of some means. And they had an estate in Bologna in Italy, and that's where he carried out his first experiments. And here you see one of his early transmitters and receivers, and still the idea of maybe an antenna, the idea of getting the waves into the air, that was still being formed. And he seeing that, okay, you can improve this. So you just adding this, taking this away. So he wasn't a scientist, he wasn't an engineer, and and that's a good thing, because all of the scientists and all of the engineers, of course, are telling him, look, what's the matter for you? Everybody knows that these waves, these radio waves, these wireless waves, whatever they are, we know that they don't go over the horizon. So why are you even messing with this stuff? Well, he knew from his work already on the estate that he was getting 1,000 feet, he was getting a mile, he's getting 2 miles, getting 10 miles. And that showed him that these predictions just weren't the case. If what the current thought was true, those radio waves would have been blocked long ago by the curvature of the Earth. And one of the experiments that he did over long range, and he would send his message or maybe just press the key, and the person at the other end just fired off a shotgun to let him know that, yeah, this I have received you. The problem was not so much technical, but financial. His father really didn't believe in this. He thought it was just a wasted amount of time. He should become a naval officer. Should do something useful. He could drive a truck, but please, leave leave this stuff alone. This is not going anywhere. But unique for the time, Marconi's mother had independent means, and we probably talked about this in the last presentation. As you can see, she's a formidable woman, and she had independent means because she was the heiress of the Jameson whiskey fortune in England. So she was herself was not Italian, and she believed in her boy, and she really thought that he was onto something. She was proud of him. And she said, look, here's my credit card. Please go down to HRO, get everything that you need. Of course, there was no HRO, there was no credit cards, there was no nothing. He just had to build everything from scratch, which is what he did. And we're going to leap ahead in time, but not by that many years. He had been getting, like we've been talking about, you know, 1,000 feet, a mile, 10 miles. We got 10 miles. Why not across the English Channel? That was always the big goal, for aircraft as well. He leaps the English Channel with wireless. If you're going across the English Channel and then you're getting 1,000 miles beyond that, why not across the Atlantic Ocean? This is the transmitter site in Paldu in Cornwall. And this was the most powerful radio transmitter ever conceived up to that time. It was, of course, a spark transmitter. And this is the antenna system that they use. Now, here they are. They're on the coast of Cornwall, overlooking the sea, where storms come in on a regular basis. Look at the construction of this antenna. Any of us could look at this and say, no, that's not going to make it. And of course, we would be right. This is what it looked like after the first storm passed through. Well, why did he build this in the first place? It was because he was going to prove that wireless messages could be sent across the Atlantic. He, and not for the first time and not for the last, bet his fortune, his reputation, his company, the Marconi Wireless Telegraph Company had been formed by this time, on the idea that this could actually happen, that you could send these wireless messages across the ocean. You could send them in a way that would undercut the people who had the monopoly on this, the undersea cables. If you wanted to send a telegram between the continents, that's the only way you could do it. And of course, since they had a monopoly, they charged the maximum amount possible. He was able to undercut them by 50% and still make money when this finally became successful. Anyway, here's the transmitting station. They re-erected it with a different antenna system that was more robust. And meanwhile, he's over in North America now, in Newfoundland, with his two colleagues. That's George Kemp on our right, and I don't know the name of the guy on the left. You notice that they're all sitting on a wicker basket, and behind them is a kite. That might not be immediately apparent, but that's what that is behind there. So their idea, they had also originally built a receiving station with a massive antenna. That too was blown down. So now they are not only going against unknown territory with a compromised transmitter and a receiving station instead of this massive antenna. They're going to try and put up a single wire with a kite. And that's what they do. All the books say that Marconi was an expert kite handler. Now, okay, I'm willing to believe that. So here they are. This is on the hill over St. John's, which is now known as Signal Hill, and there's a monument there. And they're trying to get this kite aloft. And this is in December. So they're trying to get this kite aloft, and they're struggling. And finally, they do. They get this thing up there. And of course, it lasts for, I don't know, 2, 3 hours and then flies downhill. And they get another one up there and they try everything. Anyway, they've got this thing aloft. Meanwhile, back in Cornwall, the instructions are to continue to send just the letter S, just send the 3 dots continuously, the 3 dots all the time, just keep sending them. And that's what they're doing back there. So here they are inside, and you see the receiving equipment by our lights is quite primitive. Uh, but here it is in December on the top of a hill in Newfoundland. They're freezing. They're freezing their butts off. There's no heat in the thing, in this little building that they were generously given to use for their experiments. And the receiver is based on the coherer. And some of you may be very familiar with this. This was an early version of a wireless signal detector. And you see that it's in an evacuated glass tube, and there are two plugs labeled P here coming in from each side, typically made of brass. And then between those two plugs, there's metal filings, and there's great debates about the exact composition of what those filings should be for the best operation. And this was set in between the antenna circuit and ground. And when a radio signal, a wireless signal, an electromagnetic wave was imposed on this, those filings would cohere, thus the name coherer, and the thing would pass current. So that was your detector. The problem was that after the electromagnetic wave ceased, the particles would still be cohered. So you had to have it set up as a decoherer, and typically you had to tap it. They had an automatic tapper like a bell arm on it that would tap the thing to decohere it. Now, to us, this is about as sensitive as a brick, but to them, this was it. This was what you had. And so you typically did not actually hear the radio signal. You didn't hear the Morse code. It was wired up so that when this thing passed current, it worked through an inker, a Morse inker. So you would actually print out the dots and dashes on paper tape. And that not only allowed you to see what the Morse was, but also give you proof that you, in fact, had received that signal. So there they are. And this was what Marconi used in addition. This was actually an audible indication. It's an augmented earphone. As you see, it's got the horseshoe magnet and the two coils. It's a little unclear to me how this was intended to work, or how it did work. It was intended to work as an ultra-sensitive earphone. And it's also mentioned in the literature that he used a different type of coherer that was more like we would think today of an actual detector, like a galena detector or a solid state detector. So he was using that because he wasn't hearing anything. He wasn't seeing anything on the ink tape printer. So they're just wondering, is it all going to hell in a handbasket for us here? So you will you will start a fight in a radioman's bar to this day when you say either Marconi did or he didn't receive that S on that December day, um, because he hands this thing to George Kemp and he says, "Mr. Kemp, um, do you hear anything?" And you put yourself in the shoes of Mr. Kemp. He's up there, he's freezing. All he's thinking about is getting back to the pub, having a meal, a hot meal, and getting into bed. And he says, "Yes, yes, of course, Senor Marconi, I hear it." So you can start a fight saying he did or he didn't, but it almost makes no difference because just a few years later, already there is a network of Marconi stations around the world that are linking the continents, just as he said. And here you can see the station in San Francisco that we're talking about, talking about today. So again, he risked everything. He was proven right, and he's got this network that just boggled the mind. And the cable guys all say, "Well, you can't do this. We have a monopoly on intercontinental communications." He says, "Sue me." They do. They lose. He makes money. The cables continue to operate, of course, but they no longer have this monopoly. So now we jump ahead to where he's actually building the stations around the world to complete this network. And this is the site of the future transmitting station in Bolinas. Excuse me. This is the same transmitter site that we still use today. And here you see the surveyors. They are here. And here's one thing that we just discovered not very long ago. The um, there's a map room in Marin County, that's the county we're in, that has purchased all of the holdings of the surveyors of the county, all their old maps and their notes. And we have all of that of this site. And one of the most evocative things, you see this in this guy's back pocket here. I'm willing to bet that's his notebook. They have two or three, I can't remember which, notebooks from the surveyors, from these, got to be from these guys, of their notes when they made the survey of this site for the new station. That's just, to me, that's just amazing to see. So this is what it looked like. There's the ranch that's there and the Pacific Ocean. here. So you want to be as obviously as close to the ocean as you can be, but also reasonably close to a major metropolitan area so you have access to the telegraph lines so your outgoing and incoming messages can be connected to the landline system for delivery. Here is the station as it looked when it was first completed. Still very barren, but here's this transmitter building out on the, now they called it the powerhouse. That was the term, the powerhouse. We would think of that as a powerhouse that generates electricity that we would use in our house. But in those days, this was the transmitter station, and it really deserves the name because as you'll see momentarily, the stuff in there was just amazing. And off to the right, you see there was a hotel and two cottages. And that wasn't for the public. These sites are still pretty remote, but in 1914, you can imagine how remote they really were. So the staff and the managers lived on site in the hotel and the cottages. Now, all the stuff to build this had to come around the Horn, up along the Pacific, was landed in San Francisco, and then brought here to the wharf in Bolinas. They had to reinforce the wharf to land this stuff so it wouldn't collapse when they landed. The schooner Owl was used predominantly in that, along with many others. So this stuff, here's just one example. By the way, you see nothing changes, right? Here's two guys waiting and six guys standing around. Two guys working, six guys standing around. Just, same as it always was. And here's some of the cable that they were dragging up Mesa Road up towards the Bolinas transmitter site. And it's so muddy and such a bad road, they don't even bother to try to use wheels. They're using a mule team and sledges. And look at that cable, which is just a microscopically small part of the station as a whole. Remember, they had to build the building itself as well as the equipment that's in it. And just it's worth remembering what that cable looked like because I think we see it in the finished product, which we will see momentarily. So here they are dragging this stuff up the road, and we have reports in some of the magazines of the time where after the station was built and some of the radio magazine reporters went out there to try and see it, the guy was foolish enough to go during the wet season. And he says the horses were, they were up to their bellies in mud. We couldn't do it. And those were the conditions that people were facing there. Well, here's the building. This, I think, is the earliest, well, near the earliest photo that we have. Many things to point out here. Um, and okay, I guess I have, so, but we will get back to this. I have some arrows imposed, so, but this is the general overlook. So just kind of keep this in mind. This is what the thing generally looks like. And it's still there. That building is still there. It's empty, unfortunately. All of the artifacts, especially from this era, are gone. But the building, thank goodness, is still there. This is the rotary gap, the standard Marconi rotary gap for the time. We see it rated in the literature as 230 kilowatts. And the gap itself is in the alloy housing that you see, and then over to the right, the drive for the flange for driving the thing. And this was put inside a special room called the spark chamber, which was allegedly soundproofed, all because any of you who have keyed a spark gap, especially a rotary gap, know how much noise they make. Even in the soundproof room, it was still a disturbance for folks in the area. So this was in a separate room, but here's how it looked. It's on its base before they actually put it in that room. So here's the final setup. This says the picture was taken in 1920. So this would have been the last, one of the very last pictures of this before it was scrapped because RCA had taken over the interests of the American Marconi Company in 1920. And one of the first things they did was to remove this equipment and replace it with Alexanderson alternators, which we will see in subsequent photos. So the motor in the foreground is the drive motor, and next in line is the alternator. and you see it points out there's a wheel there for adjusting the synchrony of the alternator. And then behind the wall, on the other side of the wall in the room, supposedly soundproofed, is the gap, the rotary gap. And I think what we've got over to the side there is the DC exciter, which they talk about here. And here's an overview, and you see where it goes, where the shaft goes through the wall into the rotary gap where it's actually driven. So that's the main energy producer. But up above that, on the deck above, as it says here on the photo, is the what they call the jigger gallery, and this is actually what we might consider to be the final tank coils. This is the coupling of the energy from the spark gap into the secondary coils here, the Litz wire secondary coils, and then into the tuning coils, and then out to the antenna. One of the things I really like here is, of course, this is Frankenstein stuff. I mean, this would just eat your lunch and not even think about it. But what do they need to protect people from it? Well, a sign and a nice little picket fence. That's good enough. I mean, if you're messing around up here and you don't have the sense God gave geese and you're going through that picket fence while this thing is operating, you deserve what you get. That's that's the deal. And here is where I think that it's a fair bet we're seeing some of that cable that we saw on that sledge going up Mesa Road. But there was much more to it. Here are the high pressure blowers. There is a keying relay, of course, to key this thing. Now, that's an engineering challenge in itself, a 230 kilowatt rotary spark gap that you're trying to key with Morse code. So actually turning it on isn't that big a deal, although you have to have a relay of manly size to do it. But then when the relay opens, then you've got this arc. So what you had was a blower that was aimed right at that contact. When it opened, it blew out the arc with high pressure air. So there was just so much going on here. And man, wouldn't it be great to just be able to step back in time and actually see how all of this worked? Because this was, these guys knew what they were doing. This was good engineering. Everything, all the Marconi buildings, which still exist, everything was built to the absolute top standard. It was really well done. So it would have been wonderful to just see. And by the way, this was all keyed. That keying relay, that was controlled from San Francisco, not at the site. So you'd go in and file your message with the Marconi company in San Francisco, and they would punch it up on tape. Earlier, they would actually maybe send it by hand or punch it up on punch paper tape, and that's would come up over telegraph lines to Bolinas and key the transmitter. So there was not actually any, unlike the ship to shore, there was no actual operator sending taking place at the transmitter site. Now, we're going to jump back in time a little bit because here the transmitter building has not been built yet. This is where it will exist here, but I wanted to show you this thing. Uh, this is still there, and it was one of the things that I looked at and puzzled over when I first got to the site back in 1972. It was quite a bit more overgrown, and I couldn't really tell. I'm looking at it. I said, "Is this, is it a wall that has fallen over? What is this?" The angle iron was not there, but the threaded rods were, and eventually it started to come into focus. And this is the anchor for all of the antenna wires that made up the transmitting antenna for the Marconi transmitting antenna, as well as the later Alexanderson multiple tuned antenna. So that's what this thing actually is. So it's worth remembering because we're going to see it in other pictures. So here's an overview. This is obviously the transmitter building. The powerhouse has been fully erected by now. And you see there's that anchor that I was talking about. And you see these plowed lines radiating out from the back of the building over the cliff, and then sort of radiating out towards us as we view it here. These are where the ground system was installed. The ground system was as extensive and as important as the antenna system. And you see there's this circular structure going around the building. This is also part of the ground system. So the ones that are going over the cliff, they are going over the cliff. They're going out to a plate in the Pacific. And then the ones that are going towards us are under the antenna field all the way back to Mesa Road. So it was just amazing the effort that went into getting that signal coupled into the air and having the thing have a ground system that really worked, especially here where the ground connectivity is particularly poor at this location. So here's another view of the powerhouse. And here we see this box on the side of the building. And just as I said when I was standing on that anchor and it finally came into focus. This, by the way, is one of the photos we recently got. And you look at this and look at this, and finally, one by one, things start to make sense because this is just, it's technology that was cutting edge then, and knowledge of it has just been lost. But anyway, here's this box. And we see here's what looks like a telephone pole. Okay, what's going on here? Well, you may notice that there's wires coming out from the building across the telephone pole and then down, and they're connecting to that circular structure, part of that ground system. And you see that there's these wires that come out of the bottom of the box. Those are the antenna wires. We think that in the box was an actual tuning helix, the sort of last stage of tuning before the energy was transferred to the actual antenna wires. And we'll see in a moment how that all worked. There's the anchor again, and you see that close to the anchor are these insulators, but they aren't really electrical insulators, they're mechanical insulators. This is what was holding the tension on the wires. And we'll see how this worked in just a minute. Here's a little bit closer look, and you see that, yes, okay, it does look like those wires are coming out from the bottom of that box on the side of the building. That box is long gone, but we think, okay. So you look at some other stuff there, and you see, okay, there's that pole. We saw that in the other photograph. Here's the anchor. Good. Okay, we know where we are here. And here we look back at that overall picture, and there they are. There are the two phone poles. We're going to call them utility poles, for want of a better word. And there are two, we realize now, on the backside as well. So things, again, start coming more and more into focus here. So back to here, and we see, okay, the box, and here's this window. Now we look, this is going back. Obviously, the thing is still being built here. But here we think this is where the box will be. And you see that square hole in the wall. That is where the feed line comes out into the box. It fits with the theory that there's a helix in that box as a tuning mechanism. Here are the poles. Here's the anchor. So we're oriented. We know where we are. Back up to the gallery upstairs. And we see, okay, here's a line going over this way. We think that's leading out to those lines that are coming down over the utility poles into that circular ground. And then this guy, the big one, that's going out, we say, through that square hole into that box, through the helix, and then out into the antenna. And here's a wonderful view. And you see over here on the side, that's where the jigger gallery is over there. And you see the picket fence and all the rest of it. And then the switch gear up top to make all of this run. And then down on the gallery below, the floor level is where the motors are and the stuff that we were seeing earlier. So this still exists. I mean, the switchgear sadly long gone, but the interior of the building and all the framework and everything that you see here, that still exists. And this picture almost certainly was taken from the traveling crane that is up there. You can see the track for it on the right, and that crane is still existing there. There's the what we think is the feed through out to the box where the final helix is located. So here we are looking at the outside. Yes, there it is. Okay. Now we're looking outward from the transmitter building. So again, here's that anchor. So we're looking towards the antenna. So here are these bars, and this is where the RF insulators are. So try and picture the antenna system, if you will, by going back in your mind to that original survey picture with the poles. So the way they had it set up was there were three sets of three poles, actually towers, not poles, 300-foot Marconi pattern pressed iron towers, 300-foot tall. So three abreast, then three abreast, and then three abreast. And between those was a triadic, and over the triadic were all these antenna wires to make up the antenna. They all came back to this location, insulated here where these arrows are, and then the tension kept by these mechanical insulators, strain insulators, if you want to call them that, that connected to the anchor and that bit of angle iron that we saw there. And here's another shot. So here you see the cottage in the foreground. That's the one that's nearest nearest the transmitter building, the powerhouse. And then in the middle background is the hotel, and in the farther background is another cottage. And between the hotel and the cottage on the right side, you see the tennis court. Every Marconi station had a tennis court. They really treated the staff well. Was really well appointed. Uh, and all these buildings exist. These are still with us and are now used by an organization on the site that does retreats. But you see here another idea of how those antennas are all coming down from the antenna lines from the support towers, being insulated with the insulators we see here, and then the antenna wires being taken off over to that box, the bottom of the box, and then the lines being carried on to the anchor. So a complete system, as we know, consists of a transmitter and a receiver. One's not good without the other. So in addition to the transmitter site that we've been talking about, they also had to build the receive site, and this was done in the town of Marshall, which is north of me here on Tomales Bay. And this is them bringing the equipment up what later became Highway 1. This time they are able to use wheels and horses, and all the stuff is being brought up there to build this station. And here is what it looked like taken from the sea, not really the sea, Tomales Bay. This is the powerhouse. And by the way, most of the Marconi stations around the world and in England had to generate their power online or on site. At Bolinas, they didn't have to do that. That was a vast cost saving. They were close enough to civilization that they were able to bring in power from two Pacific Gas and Electric substations at Woodacre and Alto, and they figured that gave them the redundancy they needed. And we still see those names on the switchboards at the Bolinas transmitter site. But here at the receive site, the power consumption was much less. They were able to generate their power on site, and here's the powerhouse here. And then here is the hotel, a different layout than the hotel at Bolinas. And here is one of the two cottages. And then up on the ridge line, you see the antenna masts. These are the same pattern as the ones that were at Bolinas for the transmitter masts, except they were just all in a line carrying a single wire antenna. This was not a Beveridge antenna. This was well before Harold Beveridge thought of the wave antenna. But this is what they were using as a receive antenna aimed right at Hawaii. At least that was my story. And so I wanted to make sure that I was right in that, and went up on the ridge here and took my bearings with my little hand compass. And yes, okay, it is actually aimed where I said it was. So I was telling the right information. Here is a very interesting tower, one of three or four. This is part of the balancing antenna. Now, even though this site is about 20 miles away, straight line distance from the transmit site in Bolinas, of course, the signal was still overwhelming here. And so they used the balancing antenna to pick up the signal from Bolinas and phase it against the signals that they wanted to receive. In other words, phase it out, maybe phase it against what they were receiving here with, I should say, with the signal they were receiving over their main receiver antenna from Bolinas. So they could null out as much as possible the signal that they were getting. Now, since we've done a lot of research. One of our guys has actually written a paper on this, but this is a little village, obviously here, was then called Fishermen's Italian fishing village. It is now a nice little residential area, and one of my friends lives. It may not be this exact house, but lives just about here. So I said, went to visit him, and I said, drove up there. I said, do you see any artifacts of this tower? And he said, yeah, you're parked on it. And I go out and look, and there indeed, my car is parked. My front left tire is parked on the cement base, and you can see the angle irons of this tower. So here's looking in the other direction. Here's another tower of the balancing antenna, the one we were looking at earlier down below. And it's a very, very interesting system. The narrow gauge railroad came up here down below, and then the road as whatever it was condition it was in, passed up higher here. And here's the hotel under construction, and it's just spectacular views from here. This is now a conference center, by the way, and just many, many, many more trees now, and just a wonderful, beautiful spot. Another view of the hotel. I've been through all these buildings still exist. I've been through all of them from attic to basement. They've gone through a lot of different uses over the years. Um, but you can still see the original Marconi stuff in many areas, and it's just first class all the way. And you see the tennis court in the background there. And here's a guy taking a selfie. It's not a new thing, but in the background is another one of the balancing antenna towers. This is where the balancing antenna was fed into that building, and that is the actual receiving building. That's where the actual receivers, the reception was taking place. And again, there's nobody there with earphones on copying the message like there is in the ship to shore service. They are keying circuits that go down to San Francisco where the messages are printed out on the tape inker. So this is what the whole system, how the whole system worked. Well, 1920, we already mentioned, by 1920, the American Marconi Company was thanked profusely for the service that it had provided to the United States government during World War I, and said, thank you very much, but don't let the doorknob hit you on the way out. You're done. Because the U.S. government felt that they could not have the infrastructure of such vitally important infrastructure owned by a foreign corporation. Indeed, it was the American Marconi Company, but it was wholly owned by the British main company. And what really broke the straw, broke the camel, so to speak, not the straw, was that was these machines. These are Alexanderson alternators, the most truly magnificent machines. And many of us probably know of SAQ, that is the one remaining operational alternator in the world that still operates and goes on the air periodically. So these are driven by the motor that you see on the left. Inside the uh, circular chambers is an alternator, like the alternator in our car, except it's running at an enormous high RPMs. And the rotor is a disc, a tapered disc with machine slots, and it's running in extreme close proximity to the stator. And if there's any mechanical variation, you don't have an Alexanderson alternator anymore. You've got shrapnel and wounded guys. That has never happened. So there were two of them, and they were used around the world. This was what we would call disruptive technology. It was what out made Spark obsolete for intercontinental communications. If you were going to be in the business, this is what you had to have. And Marconi was on the verge of signing a deal with General Electric to give him sole possession of this technology. And that's what the U.S., somebody called up the president of General Electric, said, no, that's, you're not going to do that. And so that was the end of the Marconi operation in the U.S. So the first thing that they did was get rid of the spark transmitter with all of its inherent inefficiencies and put in what was then the state-of-the-art transmitting equipment. So again, two Alexanderson alternators, each one 200 kilowatts. And this one was operating on about 26 kc, which is high for an alternator. And those of you who are familiar with the SAQ alternator know that it's running at about 17.2 kilocycles. So by our point, this is the basement of the radio spectrum. But this is where the action was. And everybody knew that if you wanted to go long distances, what you needed was very, very long wavelengths and gobs of power. These things could be operated in parallels. You could get 400 kilowatts, but I very much doubt that was ever done because I don't think the auxiliary equipment, the antenna tuners and all the rest of it, were equipped to handle that. And you could also modulate these. It's a continuous wave transmitter. It puts out CW. And you could modulate them. You could actually voice modulate them. That was seldom done, but it was also a way you could key them, and you could key them more easily still by our lights. Very much of a challenging engineering project, but you could key them remote, which is, of course, what they did. And here you see the gallery. This is where that switchgear was for the spark transmitter. This is where the switchgear is now, was then for the Alexanderson alternator. And here's where the jigger gallery was. So it's the same building. And here's an overview, and you see how much more was involved here in the way of tuning and modulating and regulating all of this equipment. One of our guys has actually visited SAQ, and he has reverently approached the sacred casting and touched it and then backed away reverently and not washed his hands since. So here's Marconi, still a player in the field, very much a player in the field, and he's now aboard his ship, the Electra, where he continues to carry on experiments. And he's starting to get an inkling that something is up, something is going on. And he has, I think, two, by the way, smiling again, but he has contracts to build two long wave Spark installations. I think in Australia and New Zealand, and he knows they'll work. He could do it. He could fulfill that contract, take his money, keep his word, everything good. But he's starting with his experiments to realize that the higher frequency, the shorter waves, might actually have potential. And he again put himself on the line by saying, I'm telling you, I will build you a shortwave station. I guarantee you it'll work. If it doesn't, you owe me nothing. So how about it? And that's what he does. And of course, we know that, again, disruptive technology. And this is one of the experimental shortwave transmitters that was installed at Bolinas, call sign KEL, on 95 meters. So you get an idea of what was considered to be shortwave. When you're looking at it from our point of view, that's kind of low in the low frequency wise in the spectrum. But when you're looking from 26 kc, that's pretty short. And again, I love the protective mechanisms here. You got some wrought iron pipe, and if you're dumb enough to reach in past that pipe, you get what you deserve. And you can see the tubes here, the final tubes. Don't know exactly how much power this thing was running, but they're starting to get the idea that, yeah, okay, this shortwave stuff, this might have some potential. Well, of course, that means that the Alexanderson alternators are obsolete almost within a couple of years of their being installed. On Radio Central on Long Island, where I grew up, they had plans to build, and they did build um, Radio Central with two of these alternators, the alternators on each of the compass roses. I think they had a total of 12. And they got to two. They built two before they realized this is a dead end technology because shortwaves are where it's at. And this is what the Bolinas transmitter site looked like after it was converted over to shortwave. And here you see this is the original Marconi transmitter building, just to give you an orientation out at the cliff. And here is cottage and hotel. So now get an idea of how we're looking at. And here's a brand new building built over here to accommodate the new shortwave transmitters. So here you could have multiple circuits instead of just one. You could run them simultaneously. You could make a lot more money. This was the way to go. But it also meant that the site up in Marshall was not suitable because there was no flat land for that. I mean, here we are still up, still at Bolinas, and this is from the top of one of the 300-foot masts. And you see a little something out there in the distance. Yeah, it's a rigger. I mean, these guys, they had brass ones, and I met some of them before they retired. And here's the guy, he's sliding up and down the guy wire doing maintenance. They loved the job. They loved the heights. They just reveled in it. And they let me tell you, there was nothing that was going to intimidate these guys. So to correspond to that building that we saw in Bolinas for shortwave, a new building had to be built, but not at Marshall because there wasn't enough flat land. It was built at Point Reyes on the Point Reyes Peninsula, which is where the KPH operation is now. And this was selected by Harold Beveridge, the inventor of the Beveridge antenna, the wave antenna. And I actually had the opportunity to meet Dr. Beveridge back in the 70s, and I somehow got his number out of RCA's Human Resources Office. And I don't know why they gave it to me, but I called him up and said, Dr. Beveridge, you don't know me, but I know you, and I would love to meet you to pay my respects. And he said, of course, you must, come tomorrow. And we spent the afternoon in his study on Long Island. You can imagine what that was like. But anyway, he's the one who surveyed the area and selected this, and it's right on the ocean with enough flat land for all the antennas. Now at Bolinas, you had one antenna for each city. Here, they were running triple and double diversity, space diversity. So that meant you had two or three high gain antennas, and I'm talking like stacked rhombics and fish bones and just big antennas aimed at, let's say, Hong Kong or Singapore or Sydney for reception. So for a 180-degree arc, it was like a forest of antennas there, and they all came up to the receive room on the second floor. And this is what it looked like when I got there in 1972. I took this photo. And here you see the receivers around the room and the control console in the middle. And these were obviously, since they were the last ones, I got there just in time because the point-to-point service had ended in 1973. So these are dual diversity receivers. And by 73, these were scrapped because this room was used for the installation of a satellite Earth station. But here is one of the photographs taken well before I got there, and we know several of these guys. They're sadly all gone now. But the thing that really got my attention is that you saw the name of each city above each of those receivers. This looks like Sydney, and there's Tokyo and Hong Kong and so forth. And those names are still on the transmitters at Bolinas, by the way. You still, even though they were eventually converted to Morse code service for KPH, the DIMO label saying where they were talking to, like Guam and all the rest of it, they're still on the transmitters. So all of those receivers were scrapped. We weren't there to save them. We didn't even have any idea that we would be able to do any work there. But I got wind that there was one of them in Germany. So I call up the guy and say, okay, good, you got it? Yeah, 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 I have it. So, okay, you put everything in a crate, um, put the crate on a ship, we'll give you money, send this to us. So here it is, we're offloading the crated R3 receiver. That's the designation for them. And that's my Willys Jeep. You probably saw that in the other previous presentation. So appropriate that Radio Marine Corporation of America Jeep carries the Radio Marine Corporation of America R3 receiver. So we got it, but that's only the beginning of it because now you need to get it working, get it restored. And these are not like any other receiver that you or I have ever encountered. These are cutting edge, but very, the captive oscillators and just all the rest of it. But we are blessed with the fact of having some of the brightest folks around as part of our group. And so, and here he is in his laboratory, uh, individually going through each one, replacing everything that's needed, all the capacitors, all the tubes, making power cables, aligning everything. It was a 2 year process. I've learned so much from this guy, and he knows it's just I just love to be there in his lab. He has kindly done some work for me, and it's like sitting at his knee as he goes through the troubleshooting process. I mean, I'll never be anything close to that. Especially, I mean, please, and here you see the motor driven captive oscillator down here, for example. And we brought it all back together and installed it at the Point Reyes receiving site downstairs, but it's still historically appropriate because after they cleaned out the upstairs, the last circuit, which went out to Tahiti, was in a cobbled up rack downstairs in this very location. So there was one of these receivers there historically, and it's working. So it's the only spot in the world, I think, that you're going to get to see one of these. There may be one or two others around the world, but certainly the only spot where you're going to see that here's one that's actually working. Now here is a log that is actually at that conference center I mentioned that's up at the original Marconi receive site in Marshall, where those balancing antennas were and all of that. And how they got this log, I don't know, because it's not a log of that station. It's a log of the transmitting station in Hawaii. But it's important to us because it's the log of the transmitter that is speaking to San Francisco. In other words, the receivers, the R3 receivers that we just saw. And he finally he says the transmitter is not used at night. It's a 4 meg transmitter. And down at 10:50 p.m., he said it grays out in San Francisco. He measures his final frequency. He makes all his notes like a good engineer would. So we see that this is a transmitter that's actually talking to us. This is the transmitter site, the upstairs at Bolinas, as we found it, except it's about 1,000 times cleaner. And here you see this is the RCA transmitters that were originally point to point and then later converted to ship to shore. And then the beige transmitters in the background, those are Henry HF 5000D transmitters. These were all in ship to shore service because the point to point had disappeared in 73. So this is all now ship to shore KPH service. And we started working on those Henry transmitters. It was really a challenge because this building, this building and this room was open to the air because of windows out and There was standing water in the transmitters, but all of these are working. They're just singing. They're just happy because we had the time to do it. These guys didn't. One of these transmitters go off the air. 5 seconds later, the phone is ringing. The manager is yelling, the transmitter's off the air. What are you going to do about it? Well, I'd be fixing it if I wasn't talking to you on the phone. So, that I'm sure many of us are familiar with that kind of thing. One of the transmitters called an H set was the most complex. It was an independent sideband transmitter. It was the companion transmitter to the R3 receiver. And we have I, probably 6 or 8 of them, more than that, actually. But this is the condition. This is a photo of one of the decks inside. These are the most electrically and mechanically complex transmitters in the joint. And then you're looking at this, and it's just you turn away. What are you what are you going to do with this? And we were very lucky, though. We've been so lucky. A group of engineers from Hewlett Packard joined us, and they were doing such great work. And they said, we would really like to get into a project that we could really get our teeth into. And we said, well, okay, what do you think about restoring one of these T3s? They're called H sets in the RCA parlance. What do you think about restoring one of these? Look at the condition. You think you can do anything with that? Well, yes, they could. This is it. After they had restored it, on some of these, they actually had to remachine the deck because it was just corroded through. And it was just amazing the work that they did. It took 3 years and 3,000 man hours to do it. And we have many photos of that process. And they were working on equipment that nobody but them would have had the skills and the patience to do. This is what the interior of the RF deck looks like as they were reassembling it. And the craftsmanship was just meticulous. Their work was worthy of the original engineers who designed and built this. There are areas here under the decks, for example, that once they were done are all sealed up. Nobody's ever going to see that again. But no, there's no zip ties there. There's no tie wraps. It's all laced as it was originally. And so anybody who goes back to research any of this, wanting to know what it looked like, how they did it, they're going to see the original stuff. This is not, there's no hidden things in there. It's all as it was. And this deck was in the control room. You can see some of the stuff in the background of the control room before it was moved out and placed back into the transmitter. Here is the completed transmitter. This is Steve Pizar. He's the one who did the restoration of the R3 receiver and did a lot of the work on this transmitter as well. So we're getting the thing tuned up for the first time. And it was spectacular. Really, it was, after all this work, and here's this thing. And here is transmitter 298 H set, and this was in 2013. On our Night of Nights, you may know this annual event on July 12th, we call Night of Nights. And here is the superintendent of the park, of the National Park Service of this park, and her senior staff. They're all gathered, and she's about to push the money button to put this thing back on the air. And here you see me leaning in, and I'm sure you can see the thought bubble above my head, which is, please don't let this thing catch on fire. But of course it didn't. There was no chance that it would because the work was so spectacularly good. So she hit the money button, and it's been on the air as a wonderfully reliable transmitter since then. It's on the KPH 22 meg frequency, talking out into the South Pacific. But this was originally an independent sideband receiver or transmitter. So you get 2 circuits over one frequency, and the R3 receivers were also independent sideband. And very often, with the way they did it, was one circuit was the actual revenue circuit, and the other was auto wire. And in places like Guam, they maybe only had the one transmitter receiver or Papayete. But in places like Tokyo, there were multiple ones. I think we had 6 circuits going out to Tokyo. Well, that's it. And I really want to thank you for your attention on this. I hope it made some sense. But again, I really do appreciate you allowing me to join you.
Gene, go ahead.
Yeah, yeah, can you hear me okay?
Sure do.
Okay, I am amazed at the engineering of the components that made up this site. At that time, where did they get the materials to engineer the pieces of the site? I mean, was there like a factory nearby that they gave them like drawings of what they needed and turned it over to them to make them and fabricate them? I mean, how did the engineering part develop from concept to installation?
So they were actually able to produce this stuff, and I assume you're talking about in the Marconi era.
Yes, yes, that's correct.
Yeah, so they were installing these stations around the world. So they had manufacturing and distribution and testing and engineering facilities like any large engineering firm would. And by that time, they were a very robust company.
Okay, that's fascinating. That's a nice piece of it's I kind of heard it of the past, but that was pretty much detailed, and the pictures are kind of like great.
Yeah, I'm
Right.
glad you like them. They're so amazing to us, and they're pictures of places that we walk across every day, and now you see much more, have a much better understanding of it.
Okay. Barry, how are we doing in chat?
We're very good in chat.
Okay. I'll put another call out there for questions, answers, comments. Well, it looks like Dennis has got his hand up. Go for it, Dennis.
Well, of course I do. Richard, this has been amazing and just a great addition to your last presentation that you did here. Um, I one of these days I've got to come up and visit you all. I just have not had a chance to do that. I visited way back in the 80s when I was working up at Three Peaks, but visited the KPH site. But I really want to come up and visit and see the operation. I guess you're only open on the weekends for visitors. Is that correct?
But yes, open every Saturday.
Okay.
The normal time is at the receive site from 12 noon to 4 p.m. But that's for regular folks.
Ah.
For 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 guys like us, we can make special arrangements then to do the full tour,
Mhm.
including the antenna fields and mainly the transmitter site in Bolinas. You can join us on Saturday for services of the Church of the Continuous Wave, where we have coffee and pastry and tell tall radio tales. Just let me know that you're coming so that we
I,
can make sure we're prepared for that.
I do want to do that. I do want to come up and visit. That's something that my wife Lisa and I have been talking about, that we've got to come up and visit you all. You know, you mentioned the night of nights. Um, I have to ask, is that something you'd be interested in doing a talk about before the date this year, to do a talk on the night of nights for RATPAC?
Yeah, sure. Certainly would. And I know we've been here for a while already tonight, so I won't be going into too much detail on that, but it's a very significant annual event for us. And sure, if you would like that, I'd be happy to do it.
That would be wonderful, because I'm sure a lot of folks in RATPAC would love to hear about that. They've possibly never even heard of that. And what an event. I got to tell you, um, one of the first times that I listened in on that, it brought tears to my eyes, because I was hearing, when you do the roll call of the maritime stations, one of the stations that you were calling was one that I used to learn Morse code when I was a kid. And of course, it's off the air. And that was NPG down here in the LA Harbor. And it was like a blast from the past hearing that. It's like, wow, I hadn't heard that for decades. And so it's just I've just been enthralled by that ever since. So kudos to you all for what you do in preserving that history and preserving the stations there. And it's just, you can't say enough great things about what you guys do.
We
And,
do appreciate it, Dennis. Of course, we think we're the luckiest radio guys in the world.
yeah.
And and I'm just seeing some of the comments which I missed in the past. One of them is questions, how's the station used now? And I guess we've already answered that. We're on the air as KPH every Saturday. And we have these fantasies. We used to say we're in the business of crazy ideas, and one of the fantasies, well, okay, why not go back into the point-to-point business? And the FCC probably got wind of that because they pulled those regulations. They pulled those rules from the regulations. They don't exist anymore.
That's well, just a great presentation, and I can't thank you enough for joining us and doing this. I really appreciate that.
All right, guys, it's
Great to see you.
been my pleasure. Thanks very much.
Uh-huh.
Dan, we can't hear you.
I know, but it's because I forgot to hit the unmute button. Okay, we look forward to get that scheduled there, Dennis. I look, that will be great. And Gene, you got your hand up again. Go ahead.
Yes, is there a single person or body of people that possess all the engineering specifications, technical data, drafting sheets, instructions, so to speak, concerning the setup and composition of this system?
That whole operation is now under the National Park Service. And so they're all National Park Service volunteers that maintain KPH and both the receive site and the Bolinas transmitting site. And I suspect they've got an awful lot of the documentation and engineering documents. And I can speak from experience when we dismantled the Voice of America site at Delano, that we recovered all of the engineering documentation from that site. And that's some pretty formidable engineering drawings and documentation from Voice of America. So I'm sure that Richard's their chief engineer at KPH. That's his title there.
Oh, thank you, everybody. And we'll say 73s and see you tomorrow night.